to finish a bit about raster. We won't be going deep into land cover line use because we have done that, so there will be no need for us going into that. So straightly, I want us to finish up with raster because we need to make a kind of raster, like when we are using raster calculation, when you're using Hillshade, aspect, and rest of them. So we just need to touch that to make sure that as related to the raster type of data, because we have talked about temperature, we have talked about elevation, we have talked about different types of raster like land cover, land use as related to the satellite imagery. We have talked about a bit rainfall, how you can download from NASA, my NASA data, and rest of them. So we won't be going back into those aspects again. So that is going to represent aspect of raster. Like I said, we have covered elevation, we have covered temperature, we have covered aspect of satellite imagery, which we have actually used as related to land cover, land use, both supervised and unsupervised classification. So we have talked about how you can clip raster and rest of them. We have talked about like different almost how you can also convert the point file, which we have imported aspect of XYZ, and then able to use it to create contour and move into elevation. So we have generally talked about those aspects, so we won't be actually be going back again into repeating them, though we are going to go into aspect of like raster processing, which we are going to use MV or others like processing remote sensing data. Let's say you have a remote sensing data that you need to actually enhance like atmospheric correction or removing a cloud cover. So we are likely going to use either MV or Snap Desktop to process that. And another one I was thinking we could also do is processing Sentinel-1, that is syntactic radar aperture. So we need to download any data, maybe do like deformation monitoring, or how you can generate digital elevation model using Sentinel Snap Desktop. So I think that might also be interesting to us, because but the thing is, I think most of us that doesn't have good machine, it might not work, because we really need a higher speedy laptop to be able to do that. But maybe we might, and then also for us to process a data, depending on the machine we are using or the laptop we are using, we might not be able to finish a straight processing of data from maybe beginning to the end. Why I'm saying that is because by the time you start trying to download the data, each of the data of Sentinel-1 is about, for the dual polarization, is about 7.5 gig or 7.2 gig. And by the time you download that and start the process of downloading, getting the data done that way, that's actually going to likely take us forever. So I think that one we might find a way to cut it into to see that we processed we all of us are trying to get that done. But the truth is, we need to get ready for such kind of data, because that's going to take us a bit time, though we might also build a model, like a model to help us get that done in that pattern. Because for you to download and process Sentinel-1 data, if it is using your machine, so for you to start downloading data and then do top SAS debusting, do apply obit file, and then do enhance spatial diversity, create interferogram, then go into top debusting, subset, multi-look, make filter and correction, then export and import the snap hole, and then from there you now start, maybe you want to generate elevation or displacement. That might take us a very big time, but we are going to do it, even if it is for us to spend extensive time. So we can take one chunk and able to do so. We can monitor deformation, we can generate elevation from Sentinel-1, but just know that this might be the particular license that we are going to get to. We are going to use that to do that, which is Snap Sentinel application platform. So we might also, like I said, we are going to be using as well MV and others, but majorly that is when we are going to be processing major data, like doing bit correction, as in doing something like atmospheric correction or other pre-processing. So I'll be interested in us getting to know that, to be able to use different software to achieve I don't know what this one is saying, to achieve different results. So on that, I think we will plan that, and we should be able to work on how to get that done. But what I wanted us to look at is a bit quick. We are going to work on watershed analysis. So we are going to work on watershed analysis. So I think we download digital elevation model and we look for where we are going to use water hydrological analysis. So we are going to use these tools as well. Then going back to what I wanted us to look at right now is aspect of surface, which we need to look at the aspect of slope. We need to look at the aspect of hillshade, and we need to also look at aspect itself. So on that, I might be taking off this one and take off this, and let me look for a particular data we use. So let me copy this directory, and then I'm going to add the data here. The data I download is digital elevation model. I think this is from I downloaded it from ALOS. So the same digital elevation model that we used last time. So you can also use that particular one to do this particular thing I'm going to do from here now henceforth. So I'm just trying to add the ones that have DSM, which is the surface model. So that's what I'm just trying to do. So I am selecting this. So you can as well use the data which we downloaded last time, the processes which we downloaded the elevation model. So you can also use that data, and as much as it is have to do with digital elevation model, so you can as well use that. So what I'm just doing is just to select the data which I am going to add, and then I will select one area or one tile of my interest, and then use that for this for practical purpose. So I am adding the DSM of this location, so it is actually loading. So we'll give it a short period of time for it to finish loading. So like I'm trying to say, this is the snap. So we are going to be looking at this, because for you to process radar, you need to have this, and should be able to use it to process radar. And then also we can use this in raster aspect. You can use this also to do, like, if you look at segmentation or classification, we can use it for supervised classification, where you can use EMI cluster analysis or K means, or under supervised you can see random forest, you can see KKN classifier, you can see spatial angle mapper. So these are different ways you can work with it, change detection and rest of them. So like I said, this might be a little bit big for some of us who doesn't have a speedy laptop, but we are going to find a way we are going to get that done. If not, we can build use this model builder to get it done, so that we can work on that. But whichever way, we will find a way to get it done. Now this is done for me, and let me go here and collapse all layers. So I've added the digital surface model of different places which I have downloaded, and if you look here, you see it is in Nigeria here, because this is part of the ties, different ties as related to ALOS, and then it is in Nigeria. Then I might just go straight to a particular place that I want. So maybe I can choose here, or I can choose any place I want. So whichever place I want, I can choose the particular ties I work. So here you can see, if I turn off, it is in ties. So if I turn off any layers off, you can see it going off last. So I might just turn off and leave the one I want to leave. That's exactly what I'm going to do. So this is up. So I want to use this particular one here. So with that, this is 1 2 3 4 5 6 7 8. So I want to use number 8. So I'm going to turn off everything, and then I will turn on this one. So we see here I'm going to zoom here. So this is the digital elevation model that I'm going to use, the DSM. So by going to the properties, you can see here, this is the size is 24 MB, it is diff 16 unassigned bit, and then this is the cell, and this is the row and column it contain. So as you can see, this is just the digital elevation model here, so which you can, if you open it up, if you want to see this the difference between both of them, so you can see the height differences between them. The high one is 2529, that is 596, and then the low one is minus. So you can display it whichever way you want to display it. And then this is the look here, as you can see, the low and the high. Now in here, because I have digital elevation model, so slope analysis can actually be used in different aspects, and one of the places you want to use it is maybe when you are doing land slide, and then you want to know where the different elevation, the slope as related to it. Is it how steep it is? So you can use the spatial analysis tools, and for you to do that, you come down to spatial analysis tools here, you go to surface, and then you can see slope in here. So for you to actually work on slope, so like I said, you need digital elevation model. This is to identify the slope, gradient or steepness from each cell of the raster. So with this, I am going to, because this is long, all of them are raster, so I'm just going to drag this and drop it here. And then I will also need to choose the output folder. So I want to know how steep is slope this particular place is. So I will just need to drag it and put here, because there are several datas here. So now if you look here, we have, this is the slope TF3, and we have two types of slope, which we have degree and percentage rise. Now the degree aspect have to do with the inclination that will be calculated in degree, like from 0 to, like from 0, which you have here, to 90 degrees. So from the other side, the way it is rising, this is using degree, so it is rising from the right, the left, that is the plane, upward to 90. So what I'm saying is that in this way, it have to be where you have 90, you have to start from 0, climbing upward. So the higher the degree is, the more steeper it is. Now we have percentage rise, which shows you or calculate it by percentage rise. So it is also referred as the percentage slope. So this is the two method which we can put the percentage, that is the calculate the slope. So on this, so we have the percentage rise and we have the degree. So this is the degree. In method, we have geodesic, like we know, the one that goes in 2D, that is in plane, and that which also in Cartesian coordinate, while the geodesic have to be in 3D, which majorly also, which is in 3D in Cartesian coordinate. So it is here in planar. Now in here we have one, and it is giving us warning. So sometimes we change the values, because if you look at one, if you read through this, you will see that we have here, where you have xy unit and z unit, the same unit as one, the z factor is 1, which leaves by default. Then if you go down here, it also go ahead to explain to you that you can use the z factor of 0.3 to convert your z from feet to meters. So that is 1 is equals to this. So in some cases we use this because we want to convert it from feet to meter. So if you come, instead of putting 1 and you replace it by this, and this is going to, if you look here, you see it is actually giving you a warning. And that warning, if you replace that warning with this and then you click somewhere else, you can see that the particular warning that it is giving you have actually been removed. So this is a way you can actually work on this particular aspect, and should be able to change this from this to the conversion. So once you are done with the inputting the values like this, so you can actually run this, and then when you run it, it is going to calculate the slope of this particular location for you. So the particular data set you have, so that's going to calculate the slope for you. So depending on which of the method you want, either degree or percentage rise. So for me, I am taking the degree, and then that is exactly what I am doing. So it is running, and this is the changes it have. So there is an issue here because it is actually showing me that the slope where we have 0, and then where we have it goes up to 89, which is almost 90 degree. So let me check the classes and make it into 5 classes and see what I am going to have. Let me check what is wrong, but it only just give me this part. So if you look here, you can see the different slopes that ranges from 0 to 89, but that's a little bit far and high, so it's a bit awkward. So let me check also to know what's actually the issue. Let me run it and then select the same particular data we are using and drop it here, and degree, and then let me try running it again to see what's actually happened. Okay, so this is a typical example of the result, though this actually slope is trying to signal us on something because of the degree. Now, but if you look here, you can see the percentage changes that you have between 0 to 1, which is typically telling you how flat it is. Then you have from here, you have 0 to 1.9, and from 1.9 to 3.6, and then you can see different ranges. Now the highest elevation or the highest slope here ranges from 25 to 54. So even if you look critically at both of them, so let me use snapping, and then to make this faster for me, I'm actually going to remove here to here, to remove the rest of the data so that I can only just have one, so that I will know which of them I'm going to focus. So I'm going down here also to remove this. Now I am only having these one data and the slope I calculated. So if somebody asks you, if you have a digital elevation model, then and then somebody wanted to know what is the steep or the steepness of a particular place you are working on, so you can actually use this way to determine that. So in that, I'm going to change this to put it into this, no, to the slope which we just computed now. And then if I go ahead to swipe across it using also the digital elevation model, so you can see here it's actually trying to tell us that this particular place I am swiping across, which is the radius, where we have a higher steeper slope like that. It's very high based on the legend we have, and these some other places are flat, and this is a bit flat. So for us, I can go ahead to now make it in this pattern. So if I change this to 5 and then click apply, you should also see the changes it have. Now remember what we did when we're talking about classification. Now in classification, if you make it in equal intervals and click apply, you should be able to have a kind of equal interval as related to it. So you see now that in here, where we have 0 to 10 is still green. When you have 10 to 20, you can see the changes over here. When you have 20 to 32, you can see the yellow part. So if you make it natural break, somehow you can see it is not having a good visualization, and that's why sometimes you will have different method of classification. So if you make a standard deviation, click apply and click OK, you should be able to see the difference between that and what we have now. So you should be able to see the difference between them. So we use slope in actually to check the the steepness of a particular place. So as you see here, you can see here is a bit flat and this place is not flat. So if you are making analysis like you want to make land use you want to make a sustainability map where you have which of those locations have higher slope or elevation and correlate it with where that is more susceptible to landslide or more susceptible to deformation or different, so you can actually use this method using slope to get that done. Now that is for slope. And then if you also go to Hillshade, Hillshade, we actually use Hillshade to create a hill shape from a surface by considering the illumination or source of angle on shadow. So if you have a data that you want to create a hill shape, so you can also do the same thing here. Automatically you see the here that the azimuth have actually been read, and then also this one is 45. So if you click on the modeling the shadow, so this is the type of way it's going to generate using the color. So sometimes you leave it by default, and then if you click run, so it should be able to create a hill shade for you using that particular digital elevation model which you put as input layer. So in some cases we create hill shade to be able to use the color to now check to have a kind of hill shading that is using to view how does each of them look. So if you look here, you can see that I have used this to create a hill shade. Now it uses different colors. So if you look very close to this, you should be able to see the condition of this particular area. Now so you see the way it created it from lower to higher. Where you have white is where that is high, and where you have zero it's where that is low. So with this, if you compare that with let me change this and put hill shade, and then if I swipe across this particular one, and you see, making a comparison with the elevation, you can see that if you look at the elevation, look at how it looks, and then if you look, come back again, you see that this particular hill shade were able to show us the more way the elevation looks. So in this way, I can go to the properties of the hill shade and right click on it. Then if I go down here, first and foremost, if you change the color, let me just change the color to another thing and let us see how it looks. So you can see what we have here, the way it's looking. So if you change it back to, let's make it black and white as well, the what it was, and then you look here, you can see how it is, which you can invert. Now for example, if I say I want to use hill shade effect on it more, then I will click apply. You can see what is going to change up to be. So let me use the vertical exaggeration of 100. So if you look critically, you see that these have actually changed a bit. If you apply stretch and click apply, then you can see more stretches as it is. So it was able to show you more than what it was. So if you look at the hill shade we had and what we have now, you can see more vertical elevation. So if you look there, you see, oh, this is the steeper slope. This is how it looks. So if you look here, you should be able to understand what I'm saying. Now if you overlay slope on it, and let me put up and then swipe across slope, you can see the places, the correlation between how the hill shade looks and where the slope have red, which means higher area. So if I swipe across it like this, you should be able to see what I'm talking about. So if I go back a bit, you should see that this particular region, the slope, you see it is having red, meaning that those places you see that have such kind of build up have a higher or steeper slope. Look here as well. If I swipe across it, you can see that those particular parts here have a bit of red. So you should be able to see the difference between them. Look here, you should be able to see the difference between how it visualizes. So this is a way you can use in the digital elevation model to be able to create a slope, to be able also to make a hill shade, and then this is how you are going to get it done. Now for also, there are several ways you can make, maybe you're producing a map, and which, like what I showed with us, we are going to use Blender. A Blender is a software that you just use to like make your map looks better. So we might also be using that as well. Just part of the map I shared with us, so we can finish up with this and we overlay to be able to visualize a map that looks maybe more aesthetically clean or better. Now this same thing here, You remember here image analysis, you should be able to look at it. If you look at curvilinear, you can see the difference between what I have now. So these are different interpolation method which you can use in visualizing your map. So if you look here, majority, you should be able to see the difference between them. Now it is in majority, and if you look at it, you can see the pattern. This you are not able to see those parts you see there. Then this is cubic convolution. You can see the way it is. This is bilinear, which uses 16 gig neighborhood, 16 side neighborhood, and then this is nearest, which uses 4. So you can see the difference where you can actually manipulate raster. Now over to aspect. Now what is aspect? Aspect actually shows you the aspects which derive from the aspect for each of the cells. So it actually identifies the direction of that particular surface or each of the cell. It shows you the direction. So for example, if you want to know which part is it looking like emanating from the sun, so you should be able to use aspect to get that. So aspect identify the compass direction that the downhill slope faces for each location. Now what I mean is, any parts of this, you should be able to know where does it face. Does it face right, or does it face left, or does it face up or down? So whichever said, it is also classified into almost 8 different parts, which is north, south, west, southeast, south west, northeast, and northwest. So with this, you should be able to know which direction does this particular face, each of the surface face. For example, when we are walking, we sometimes use this data to know, like in surveying, we use sometimes we see the north arrow. The north arrow is not just only showing you the north, it also helps the architect to design the building, to be able to check which direction is the sun striking the building, so they know which best way to orient it. So what I'm saying is, this particular shows you where it is. So it is now trying to tell you that this particular place here, it is flat based on the digital elevation model that we feed it in. And remember, I just used the Hillshade, I didn't use the digital elevation model, so there should be difference. So this is trying to tell you that this particular area is flat, which is -1. Now the places you are seeing red faces the north, which is between 0 to 22 degree. Now if you look at this, you see it started from 0 down to 360, trying to show you which direction does it face. So on that, I'm going to remove aspects. I'm going to load aspect again, and this time I'm going to use digital elevation model, which we're using to be on, not using the I don't want to use the Hillshade, which I used earlier, because the Hillshade is already in another format, so I should not be using. So let me use the digital elevation model, so that all of them can be derived, or all of them can be extracted from digital elevation model. So if you see now, you see there is a difference between what we had and what we have currently. So what it means is that with this, you should be able to know which direction is the sun, or which direction is it facing down the slope. So if you look at this, you can see that this particular place, which is green, is facing southeast. This particular one, which is red, is facing north. As you can see, this particular direction, you should be able to have which of the direction are they facing using this. So if you look here at the drop down here, you can see that the north is red, which is between that angle, the northeast, the east. So this is a way you can actually get to know which direction is it facing down hill. So this is a way you can get it done. So if you look here, you see this is 10. Now if you say reclassify to 4, you should be able to see maybe it is facing east, west, south, and north. So it is now in 4 format. So let's use color so that we can use the color to differentiate them. So if you click apply, you should be able to see which direction are they majorly facing. So what I'm saying is that by looking at it, you can see that this one is facing between 0 to 89. So the green one is facing the east side majorly. So any place you see the green means that if the sun is rising or coming from the east, it is majorly facing there. So if you look here, you see here where my cursor is, this is east, east, east. So you can see the direction perfectly. See that all of them are facing in this direction. Maybe let me use the aspect and try checking which of the interpolation method can make it better. So let me use check linear. So yeah, if you look at it now, you see, understand what I'm trying to say. So as example here, you can see here right now, it is trying to tell us that it is between the aspect of east, like, so anytime the sun is rising, that is 0 to 90, for example, depending on where you are, then this is actually where that you are going to be. This place is going to be where the illumination downstream is going to face. Now if you look at this as well, you can see the different ways it is. So let me check by linear. So you see what I'm trying to say. I can also decide to like go down here. Let me also try to use Hillshade. So but the whole thing is, what I'm trying to say is that in nutshell, you should be able to use this to know which direction is the sun facing, which direction are you having a kind of the illumination downstream. So let me make the Hillshade. So what I'm saying is that this particular part we have green, it is 0 to 90, that is the side it is facing. This particular part we have green, it have to be between 80 to 1, that is 189, which is 90 to 180. Then this part that we have this color faces the angle of 179 to 270, and then the rest of the road you are seeing faces the side of the angle of 269 to 360. So by looking at this, you should able to know which direction have more illumination or downstream to the east. As you can see, this side have more, this faces more of the north, and you can use it to determine which direction it is. So this is generally what you can do with raster. Now before we go, I also want to touch aspect of reclassify. Now, reclassify is really important, especially when you want to put a particular data in a particular interval. So you reclassify or change the value in the raster or any data set that you have as related it to raster. For example, if I want to use the slope, I'm going to use slope as example, and then I want to reclassify it. If you have a value that you have inside the slope, you can use that. But what I want to say is that I want to change this into a particular format, because sometimes when you're doing raster calculator, you're doing susceptibility map, you should understand that maybe you want to make a raster calculation. Now you want to put this thing between 0 to 1, give it a new value as 1. Between this to this, give it a new value as 2. So when you do this classification and you want to multiply them and say that you want to make a raster calculation to say that this particular is susceptibility, the susceptibility is okay for, maybe you want to do maize, for example, and you want to do maize, check where that is okay for maize, and then you have also seen that the elevation of this is not good for maize and the elevation of this is good for maize or not. So what you do is that you can group these things into the categories like this. So now I am assigning new value to them. I can change the value, like you can see here, this is 1, this is, I can also change the value to what I want to put it, but I want to leave it by default to 1 and 2 as it is. This is the old value. You can also regroup this old value to what it is. You can revise the value by this way, or can you, the way I'm revising it. This is the precision. You can also change the precision of it. So by maybe you make it into a smaller one like 3 and you click OK, and that's actually change the precision. Now you can change the missing value to no data. Where there is no value, make it as no data by checking this. Now what am I doing? I am doing reclassification, which is exactly what I'm doing. So I am actually reclassifying. So in the reclassifying, like I said, you reclassify to fit into the kind of the data you want to put it on. So that is exactly what I'm trying to do. So I am doing a reclassification. So once I am done here, I can click OK, and once I click OK, that's going to reclassify it into 5 for me, assigning those new values to it. So this is how you are going to get it done. So now the reclassification is almost done. And then you can see now what happens. It have reclassified this thing into 5 parts for me. Now for example, I want to also reclassify elevation, so I'm going to click on that elevation, and then this is, I've seen the new value it gives to me. Now if I want to reclassify it as the same thing as 5, so I'm going to change this into 5 as well, leaving it into natural break, and you can see here the way it is. Change this to missing value, you have this. So this is elevation, and I also want to reclassify it. So if I reclassify them, what did I do? I have set the data set into the same size, and all of them are in the same size, so both of them have the same value, 1 to 5, and the other one is going to have 1 to 5. So maybe I want to do sustainability map to know where it is matching, so I should be able to get that done. Okay, so when you are done with this, so the next thing you can do is you can use Raster Calculator, which we can call here as math. So there are different kind of these things you can do here. You can multiply, you can do a lot of things here. So assuming you will have a particular thing you want to multiply, you can use different. If you come here, you can see mass, so you can see bitwise. There are different this thing you can do here, which you can actually make a kind of multiplication. This is raster calculator, which is math. Then but I want us to use the raster calculator, which is map algebra. Now what I'm saying is that in this, you can see here I can multiply raster against another raster. Now if you see here, you see I have the first raster here, which I can multiply with the next raster. Like I say, if you want to do a sustainability map where you can make a kind of multiplication, so you can use this kind of method to multiply one raster against another raster, like what I'm trying to do. So if you have something that you want to actually work on, so you see the first one here is raster here, algebraic, return back here. The first one here, if I want to make a multiplication, like you have something interesting you want to multiply, so you can multiply a raster against another raster. So with this, so what am I trying to say? Remember that I reclassify them so that both of them can be in the same part. And then the next thing I could do is to set out the output where I want it to be here. So in raster calculation, so that's exactly what I want to do. So I want to calculate the raster here, and this is where I want to save it. So in this, like I said, if they said which land is suitable for agriculture, like planting of maize, or which land is suitable for a particular purpose which you have known, so you can actually use this to classify, make this kind of this. So you assign weights to it, and you should be able to say that this particular place is okay for it, or this particular place is not okay for it. Now if you look at what happens, you see that I have 5 input and now I have 25 output. So with this, if you open the attribute table, you should be able to see the different counters you have here. So it have made a calculation using this raster. So now for example, if I say that this place, I want a place that is sustainable to maize or whatever, with this I should be able to get this, because the raster have been calculated with each other, and it should be able to show me that this particular place is okay for it or not okay. So you can group it in this way and able to make this kind of calculation. So by your research or whatever you're doing, you can tell us that based on the raster calculation output you have, then this will be okay for you to plant maize, or because of this it won't be okay for you to plant maize, so it will be okay for yam or this. So what I'm saying is, when you are doing this kind of analysis, you should be able to know what you want. Maybe it is soil pH that you collected, or water pH, or whatever you measured, and you can put them in these tables like I put it in this range. Then with this I can say that this is okay for this and this is not okay for this. That's exactly what I'm saying. So example I use is, I use the elevation and slope, and if I want to say between this raster I have calculated, which place is higher for For example, I want to say which of these places is have high prone for landslide. With these particular things I did now, you can see here, I can actually tell you that this particular place you see red here have higher chances for landslide, or any place you see green is okay for maize cultivation. The place you see white is okay for any kind of thing. So you can name it depending on what you have find out that the ranges are okay. So you make a raster calculation and you come up with us that to tell us that these people, this particular region, if you cultivate maize here, it will be okay. If you cultivate yam here, it will be okay. If you cultivate this thing here, it will be okay. So you should be able to use this method and then able to say that this is how best it is for, just like I did here. And I can actually say tell somebody that between this range is okay for this range is okay for this, or it is not okay for this. So this is a way you can make a multiplication or do raster calculation and come up with a sustainability map. You can multiply more things. It's not just only 2 rasters. You can make it up to 3 rasters or 4 rasters depending on what you're calculating. Like if you want to develop a kind of model, so you can also check it using this method. So for me, I just used about 3. You can see 4. So I can say that because this place have a low land and I've multiplied 2 rasters, which is slope and elevation, I should be able to say that this particular part here that you see green are habitable, so people can stay there because it is flat. I have multiplied the steeper slope together with the elevation. So this is actually okay for people to live. But this part might be okay, but this particular place you see here, it is very, very hard for people to live. Now if you look at both of them, look at the aspects, you can see a direct correlation between both of them. Like for example, if I turn on, let me turn on raster and change this thing to raster calculation. So if you look at this, you see that the part I am having, you can see the top side here, they have a very high steep slope. So if it is the raster which I multiplied, which is elevation and slope, can show you the sharp difference between these two places. So if you look at what I'm swiping, you see here have a high risk. If it is a risk for landslide, you see this place have a higher risk than this place for landslide. So if it is for maize or agricultural cultivation, you can tell us that this particular place have a higher chances of maize to survive, but this place have a higher chances of groundnut to survive, and this place have a higher chance of yam to survive depending on what you are doing. So this is a way you can make a sustainability map to know which place is suitable for one thing or the other. So by the time you bring this kind of parameter, as you multiply the raster, you should be able to get that. Remember, while you're making a raster multiplication, there are some of the things you should have in mind. And one of the things you should have in mind is make sure that what you are multiplying, the cell size are the same thing. And that is the reason why I have to make a multiplication by putting both of them into those categories. What I mean is that, for example, if you have a place that have this kind of steeper slope, it might not be able to hold water. Like I said, there is a kind of crop you are going to cultivate within the place that have a higher slope, it won't survive. But with this, you should be able to use that, make a raster multiplication and tell us that, oh, this place is okay for this and this place is not okay for it. Is that okay? Did you understand what I'm trying to explain on reclassification?